So far, we've learned several derivative rules. The power rule, which is probably the easiest rule, the constant multiple rule, the rule for constants, the sum and difference rules. So today we're going to work into the transcendental functions, the trigonometric functions, starting with sine and cosine, and the exponential and natural log function. You can see on your laminated sheet that the derivative of the sine of x is the cosine of x. What I'm going to do here is show you why that is so using the definition of derivative. And then we'll do it again for the cosine function and might do it again for tangent when we get to that. But all of these rules can be derived using the definition of derivative. So if the function is sine of x and I want to find the derivative, I know that that is the limit as h approaches 0 of f of x plus h, so that would be sine of the quantity x plus h, minus f of x, which is sine of x, all divided by h. In order to simplify that, I need to use the sum rule for the sine function. This is a rule that is in the back end sheets of your textbook. You learned in math analysis or trig. Sine x cosine h. Yes, cosine, I usually do cosine x sine h, but either way is fine. Very good. Sine of the first times cosine of the second plus cosine of the first times sine of the second. And then I have the sine of x that I'm bringing down. At this point, I'm going to rearrange the terms to make it easier to understand the factoring that will take place in the following step. So I have the first term, and then I'm going to put the minus sine of x next, and then bring down cosine x sine h. Notice that those first two terms have sine of x in common, so I can factor out the sine of x, which will leave cosine h minus 1. At that point, I'm going to split this sum into two fractions so that I have the limit as h approaches 0 of sine of x times cosine of h minus 1 all divided by h plus the limit as h approaches 0 of cosine x sine of h all divided by h. Well, if we're finding the limit as h approaches 0, sine of x is a coefficient. So is cosine of x. So I can factor out sine of x and multiply that by the limit as h approaches 0 of cosine h minus 1 all divided by h. And I can factor out cosine of x, again since it's just a coefficient, to be multiplied by the limit as h approaches 0 of sine of h over h. We learned two special trig limits. One of them was involving the cosine of h minus 1 over h as h approaches 0. We learned that that limit was 0. The other one was the sine of h over h as h approaches 0, and we learned that that one was 1. So therefore, we find that the derivative of the sine of x is cosine of x. This isn't something that I would expect everyone could just jump in and do. I would hope that you could follow it. I know that it's been a while, and this formula right here is not one that we use very often, but I did want you to see why the derivative of sine of x is cosine of x. Bottom line is you need to know it. Questions on that one? Now on your laminated sheet, again, you'll see all these u's. The sine of the derivative of the sine of u is the cosine of u times u prime. What that will involve is when our variable right here is a complicated variable, not just a plain and simple little x. If it's a 2x or an x squared or an x plus 3, there's more involved, and we'll get to that when we study the chain rule next week. Okay, so let's do a similar thing and derive the formula for the derivative of the cosine of x. What do you see that it is on your sheet? Negative sine of x. Okay, so f prime of x is the limit as h approaches 0 of f of x plus h, which will be cosine of the quantity x plus h, minus cosine of x all over h. The steps are similar, but the formula for the cosine of a sum is different than the sine formula. Travis, do you remember this one? Very good, you do subtract. This one is cosine, cosine, minus sine, sine. They're just not formulas you use that much, so it's understandable that you wouldn't remember them. So again, I'm going to rearrange stuff just to make the factoring look more reasonable. You can certainly factor without rearranging. And I'm going to slide that minus cosine of x into the middle position. So it's easier to recognize that those first two terms have a common factor of cosine x. So I factor out the cosine x, and that's going to leave cosine h minus 1, and then just bring the other one down. And then, as we did before, we're going to split this into two limits, separate the fractions. So we have the limit as h approaches 0 of cosine x times the quantity cosine h minus 1 all over h, minus the limit as h approaches 0 of sine of x times sine of h all over h. We can again factor out the cosine of x and the sine of x because the limits are as h approaches 0, so those terms are coefficients. So cosine of x times the limit as h approaches 0 of cosine h minus 1 all over h, and sine of x times the limit as h approaches 0 of sine of h over h. From our special trig limits, we know that this first one is 0 and the second one is 1. So that tells us that the derivative of the cosine function is negative sine of x. You will need to know that. Okay, let's look at some examples. Find f prime of x for each of the following. The first example involves the constant multiple rule. The derivative of 2 times sine of x is 2 times the derivative of sine of x, which is cosine of x. In this next example, I would probably rewrite it first. Again, your book may use this notation because it saves space in printing, but this simply means 1/2 times sine of x. So the derivative is going to be 1/2 times the derivative of sine of x, which is cosine of x. So in the next example, we have a mixed function. We have a polynomial variable, I guess you could call it, and then you have a trigonometric function. Just take the derivative of each part using the appropriate rule. So y prime, the derivative of x is 1, and the derivative of cosine of x is minus sine of x. In the next example, we have an application. Determine the points, if any, at which the graph of the function has a horizontal tangent. If there is a horizontal tangent, that means that the slope of the curve is 0. Horizontal lines have a slope of 0. A tangent line to a curve gives you the slope of the curve at that point. So if I want to find these points, I need to set the first derivative equal to 0 and solve for x. The first derivative, square root of 3 times x. The x is not under the radical. That's very clear. When we write that, it's probably better if we were to write the variable in front of the radical because we tend to be a little sloppy. But with printed matter, it's clear that x is not under the radical. If it were, it would be extended. Okay? So make sure you interpret the problem correctly. So the derivative of square root of 3 times x is the square root of 3 times the derivative of x, which is 1. The derivative of 2 times cosine of x is 2 times the derivative of cosine of x, which is negative sine of x. Now, when you get into doing these, you could certainly skip that step and write it as square root of 3 minus 2 sine of x. But there's no need to get in a hurry until you understand the rules and learn them well. So there's the derivative. Now I need to set the derivative equal to 0 and solve for x. Well, to solve for x, I first need to isolate the trig function. So what I would do is add 2 sine of x to each side of the equation to make it positive. And then I would divide both sides by 2. Pay attention to the interval given for x. The x's we are looking for fall in the interval 0 to 2 pi. So what I'm looking for now is all of those angles that have a y coordinate square root of 3 over 2. If you have your families handy, the pi over 3 family is the one with this ordered pair, cosine, sine. So that tells me that x must be pi over 3, and then I need to remember the other quadrant where sine is positive. What other quadrant is sine positive? 2. And so what is the angle in quadrant 2 that has a y coordinate of square root of 3 over 2? 2 pi over 3. Unit circle. So determine the points. Are these points? What is it? How do we represent a point? Ordered pair. So I now know the x coordinates. If x is pi over 3, my point will be pi over 3, comma, whatever I get for y once I put pi over 3 back into the original equation. So y equals square root of 3 times pi over 3 plus 2 times the cosine of pi over 3. Yuck. I would write that as pi times square root of 3 over 3 plus 2 times 1/2, or pi times square root of 3 over 3 plus 1. So that is the y coordinate for that x. Find the y coordinate for the other x if x is 2 pi over 3. The exponential function is a very special function. The graph of the exponential function, e to the x, that's one you know. You can draw it blindfolded. It's always increasing. It has a y-intercept of 1. Look at the slopes of tangent lines as we move around that function. Right here, the slope is very small. It's not quite 0, but it's getting real close to 0. And as you move around, the slope increases a little bit more. At this point, the slope is 1. And as we move around, the slope is positive, still increasing. So if we were to plot those slopes, can you picture, anybody take a guess as to what we might see, what the graph would look like of those slopes? Starting out very small, not quite 0, and then a little bit bigger, a little bit bigger, keep getting bigger, slope of 1, then slope of 2, 3, 4, 5, 6, 7, 8, 9. When x is way over here, would it look like what? Exactly. Excellent, Travis. If we were to plot all of those slopes, over here the slope is almost 0. It's a little bit bigger, little bit bigger, little bit bigger. The slope increases. Here the slope is 1. Then the slope continues to increase. Plotting those slopes gives us the same picture as the exponential function. What that tells us is the derivative of the exponential function is the exponential function. It's the only function that has its own derivative. The derivative of e to the x is e to the x. Learn it. So now you have 3 new ones. What's the derivative of sine of x? What's the derivative of cosine of x? What's the derivative of e to the x? Yay. Okay. So find the derivative. The derivative of 5 times e to the x is 5 times the derivative of e to the x, which is e to the x. So 5 e to the x. In the next example, we have a mixed function. Part of it is polynomial, part is exponential. Functions of this type are very difficult to solve without the aid of a graphing utility or a computer because your variable is in the exponent and also not in the exponent. But we can find the derivative very easily. What would you think? 6x plus e to the x. Very good. In the next one, we have a mixture of a trigonometric function and an exponential function. What is the derivative of cosine of x? And what is the derivative of e to the x? So there's the derivative.
We could have a test the whole page on just those. Well, yeah, well, there's anything that has e to the x in it. I get those right.
Good. And they are easy. We'll do more complicated ones again. If you look at your laminated sheet, you'll see this e to the u deal. And the derivative of e to the u is e to the u times u prime. That simply means if I have e to the 2x, for example, for my function, and I'm getting ahead here, but the derivative is going to be e to the 2x times the derivative of 2x. So 2e to the 2x. We'll look at more of those next week. Okay, moving on now to rates of change. As we've talked about before, the slope is a rate of change in y with respect to the rate of change in x. Other types of rates of change: population growth rate, production rates, water flow rates, velocity and acceleration. They are rates of change, and they are one of the most common applications that we'll work with, especially here in the beginning. So this next example that we'll get to will be about velocity and acceleration. An object moving in a straight line, either horizontal or vertical. If the movement is to the right or upward, we call that a positive movement. Just like it sounds, you know, if you're going up, that's positive. If you're going to the right, that's positive. Think of the coordinate plane, the positive y-axis, the positive x-axis. But if it's moving to the left or down, then we think of that as negative. Okay? The function s that gives the position of an object relative to the origin as a function of time is called the position function. It's giving the position of the object, the position function. The change in s over the change in time, delta s over delta t, is the change in distance over the change in time. Average velocity, I think this hopefully printed more clearly on your sheet. Average velocity is the change in y's over the change in x's. That's just the slope formula. Average velocity is the slope formula. To find instantaneous velocity, which we referred to simply as velocity, the velocity is the derivative of the position function. Velocity is the derivative of the position function. The position function is s of t, so the velocity function is s prime of t. And s prime of t is this limit thing that we know to be the derivative, and we're learning rules to do it much more quickly than using that definition. The position of a free-falling object, neglecting air resistance, under the influence of gravity is, does this look familiar? Are you in physics? This class takes physics, right? S of t equals 1/2 gt squared plus v sub 0 t plus s sub 0. Do you know what all those things represent? Yay! In physics, most of the time you probably work in meters. In here, we'll work in feet and meters. So please pay careful attention to the problem to make sure that you use the proper gravity coefficient and the proper units. All right, example. At time t equals 0, a diver jumps from a platform diving board that is 32 feet above the water. The position of the diver is given by s of t equals negative 16t squared plus 16t plus 32. S is measured in feet, t in seconds. When does the diver hit the water? Well, what this is asking me is to find t. Find t when the position above the water is 0. When the diver hits the water, the position above the water is 0. So I'm finding t by setting the position function equal to 0. To solve for t, we can factor I'm going to factor out a negative 16, which will leave me with the trinomial t squared minus t minus 2. And then I can break that down into two binomial factors, t minus 2 and t plus 1. Setting each of those equal to 0, I get t equals 2 and t equals negative 1. When does the diver hit the water? In 2 seconds. If units are given in the problem, units are expected with the answer. Question on that part? What is,
Where did you get the 2 seconds from?
when I solve for t, I get two answers for t, and t represents time. Time can't be negative, so we reject that answer and accept that t equals 2. Does that answer your question? Okay. The next question, what is the diver's velocity at impact? Well, first of all, we need to know the diver's velocity. We need to know the velocity function. The velocity function is the derivative of the position function. So the velocity function is going to be, using the power rule, because that applies here, negative 32t plus 16. I'm multiplying the exponent 2 by the coefficient of negative 16 and reduce the power by 1. Same thing for the middle term, 1 times 16, reduce the power by 1. What's the derivative of a constant? 0. So there is my velocity function. I want to know what the diver's velocity is at impact. That means evaluate this velocity function for a specific time. Well, what time would I use to find the velocity at impact? Why do I use 2 seconds? That's when he hit the water. Very good. So velocity at 2 seconds is negative 32 times 2 plus 16. Negative 64 plus 16 is negative 48 feet per second. Why is the velocity negative? Because he's going down. Movement downward is negative. Okay? We doing all right? In calculus, many times you're analyzing particle motion. The position function of a particle moving along the x-axis is given by s of t equals t squared minus 3t plus 2, where time goes from negative infinity to positive infinity. So what that's saying is this little particle is moving back and forth, or maybe it only turns around one time, but he's moving right and left. We're going to analyze this to see what the little particle is doing. Find the velocity of the particle. How do we find the velocity if given the position function? Velocity is the derivative of position. So velocity is what? 2t minus 3. That is the velocity of the particle. It didn't ask me to find the velocity at any specific time. That is how I find the velocity of the particle. Find the open t intervals in which the particle is moving to the left. Well, I will know when the particle is moving to the left if the velocity is a negative number. I know when it's moving to the right if the velocity is a positive number. So to determine when the particle is moving to the left, I need to know when is the velocity negative. Even though this is a pretty basic and simple problem, I'm going to set it up the way that will work for you for all problems that get more complicated. This little particle at some point changed direction. It changes direction when the velocity is 0. So I begin by finding, bless you, at what time the particle changes direction. So I set the velocity equal to 0 and solve for t. So at time equals 3/2 units, it changes direction. If I analyze the velocity in a little sign chart, starting with negative infinity for t and going to 3/2 units, and then 3/2 to positive infinity. I want to know what the sign is of the velocity in each of these intervals. The particle only changed direction one time at t equals 3/2. So the interval from negative infinity to positive infinity is broken up into two pieces. So from negative infinity to 3/2, the particle is going in one direction, and then from 3/2 to infinity, it's going in the opposite direction. To determine what it's doing, pick a number in the interval. A number between negative infinity and 3/2. 0 is a good one. If I put 0 in for t, will the velocity be positive or negative? The velocity is negative. That means the particle is moving to the left. In the next interval, 3/2 to infinity, pick a number, 2. 2 times 2 minus 3 is a positive number, so the particle is moving to the right. The question said find the open t interval or intervals in which the particle is moving to the left. So we say it is moving to the left in the interval negative infinity to 3/2 since the velocity is less than 0. You must state that. Don't just draw this little chart and have your minus and plus and stop. Then you're asking the reader to interpret what you found. You need to state what that told you. That's called justifying your answer. Okay? Next, Find the position of the particle when the velocity is 0. What do we use to find the position of the particle? The position formula. And what was the position formula that we were given? Okay? And I want to know the position of the particle when the velocity is 0. Do I put 0 in? Why do I put 3/2 in? The velocity is 0 at t equals 3/2. So that's why we put in 3/2. Okay? So that's going to be 3/2 squared minus 3 times 3/2 plus 2. 9/4 minus 9/2 plus 2. Oh, I can't move that down. Okay. 9/2 is 18/4, so 9/4 minus 18/4 is negative 9/4 plus 8/4 is negative 1/4. So on the x-axis, it's a little left of the origin. S of 3/2 is negative 1/4. We weren't given any units, so we can't give units with the answer. Find the speed of the particle when the position is 0. Speed. If you're in your car and you're going forward, your odometer says 20 miles per hour. You're going 20 miles per hour. That's your speed. What if you're going in reverse and it says 20 miles per hour? So what am I getting at? What is speed? Absolute value. It's the same in either direction, but it's positive. The speed is the absolute value of velocity. Okay, so let me write that down. Speed is absolute value of velocity. So I need to find the speed when the position is 0. When is the position 0? Do I know? Do I know when the position is 0? We haven't found that, have we? Okay. So first of all, when is the position 0? I need to take the position function and set it equal to 0. I can factor this. Can you? And I will find that the position is 0 at t equals 2 and t equals 1. Doesn't that kind of make sense since we found that it changed direction when t was 3/2? Okay, so now to find the speed of the particle when the position is 0, to find speed, we use the velocity function, but we take the absolute value of it. So we want the absolute value of v of 2. And what was the velocity function? 2t minus 3? Okay, so the absolute value of 2 times 2 minus 3 is going to be the absolute value of 4 minus 3, which is 1 unit per second, or 1 unit, we don't know the time. 1 unit, we'll say per second. What is the velocity, the speed, when t is 1? It's also 1. Okay? Questions? All right, here's that example that I had out of whack on my slides. Find k such that the line is tangent to the graph of the function. We may have actually done this problem before, but these were the ones that some of you had trouble with. If it's tangent, it's touching, and the derivatives are equal. So we set up two equations. K minus x squared equals negative 4x plus 7. And we also need to set the derivatives equal to each other. K is a constant, so f prime of x would be what? Negative 2x. And y prime? Negative 4. So for this one, we can solve for x. We can then replace x in the other equation and find k. So k minus 4 equals negative 8 plus 7. K minus 4 equals negative 1. K equals 3. Does that problem seem familiar? Okay, I didn't know if I was having a deja vu or something.
We did. It was like negative 6x plus something. Negative 6x plus 1.
Okay. All right, do you have any more examples? Okay. Find all points at which the tangent line to the curve is horizontal. That means the derivative is 0. Vertical means the derivative is undefined. So it all hinges on the derivative. In the first example, what would be the derivative? Okay. So I can determine where that is 0 by setting it equal to 0 and solving for x. Solve by factoring. So when will this derivative be 0? When? Okay. But it said to find all points. Very good. When x is 0, plug it back into the original. Very good. When x is 0, what is y? And when x is 4, 64 minus 96 plus 1. So negative 31. Okay. And the other part of the question was to determine where the tangent line is vertical, is this derivative ever undefined? So it has no vertical tangent lines. Whoops. And last example, same directions. What is the derivative of x to the 2/3?
2/3 x to the -1/3.
Very good. We okay, everyone? Power rule. You multiply 2/3 times 1, decrease the power by 1. So I need to set that equal to 0. And to be able to work with that more easily, I need to express with a positive exponent. How can we rewrite that expression using positive exponents?
2 over 3 cube root of x.
Okay,
Or
2,
we could just say x to the
2 over 3 times the cube root of x, or just 2 over 3x to the 1/3. Very good. That is much easier to work with than the negative exponents. So, I have a fraction. What has to be in place for a fraction to equal 0? Or how do you determine where the fraction is 0? How can you get 0 out of a fraction? The numerator has to be 0. So to solve this, you set the numerator equal to 0. Well, is that ever going to happen? So that means no horizontal tangent lines. Now, for vertical tangent lines, we need to know where it's undefined. How do we determine where it's undefined? Set the denominator equal to 0. So 3x to the 1/3 equals 0. Solve for x, divide by 3, cube both sides. So when x is 0, we have a vertical tangent line. But it said to give the points. So when x is 0, what is y? 0. This is the one that I think some of you said looks like a bird. The graph looks something like that. If you want to graph it on your calculator, you can see. But at 0, you have a vertical tangent line. That's a cusp. It is not differentiable. It means the derivative is undefined. Okay, very good.